Good morning, Morgan, and good morning to any of Morgan's friends that have joined us for today's video. And we're going to continue talking about using the find and the find all statement to find what exactly it is that you need to find in the HTML code or the XML code for that matter. So with that, let's just go ahead and get the reading started.
Now we're ready to look at the search methods in detail. Find _all.
All right, I don't know what that means. All right, I know, let's see, name. These must all be attributes, maybe? Or parameters you can use in the find all? Is that what that stuff is? Let's see. How do I get this? I want to restart this.
The find _all method looks through a tag's descendants and retrieves all descendants that match your filters. I gave several examples in kinds of filters, but here are a few more.
All right, some more examples. All right, so find all title, and it found the whole title tag. Now we go P title. Okay, so we're looking for two things. We're looking for anything with a P tag or with a title in it. And here we've got the P tag, and buried within the P tag. Oh, why is the B? Oh, it's the child. It must include that because the title is a string in the right after the P tag. All right. Then we do the anything with the tag A, and we get the three sisters, like you would think. Now we're going like, hey, look at the ID attribute, and we're interested in anything that's equal to link to. Okay, so, and of course that works with any of these attributes, whether it's a class, this href, ID, you get it. Now here we bring in the RE library just because we need these. For some reason, we need to run it through this compile sisters. I suspect that has to do with getting the string into the proper format so that you can use the find. Now, again, with the find, we're only going after one of these things. We're not going to be searching around for all the sisters. And here we found it in the literal. Okay. All right, now let's go on and do some more reading.
Some of these should look familiar, but others are new. What does it mean to pass in a value for string, or ID? Why does find _all, P, title, find a less than P tag with the CSS class title? Let's look at the arguments to find _all. The name argument. Pass in a value for name and you'll tell Beautiful Soup to only consider tags with certain names. Text strings will be ignored, as will tags whose names that don't match. This is the simplest usage.
All right, okay, so we're finding all the title tags. Yay. We've done that.
Recall from kinds of filters that the value to name can be a string, a regular expression, a list, a function, or the value true.
All right, okay, so it can be a string, some sort of an expression, a list, a function, and a value, right? I guess this ID equals link to would be considered an expression.
Any argument that's not recognized will be turned into a filter on one of a tag's attributes. If you pass in a value for an argument called ID, Beautiful Soup will filter against each tag's ID attribute. Soup.find _all ID equals link to.
All
Hashtag,
right.
a class equals.
Stop. All right. Okay, so this is considered an argument. Okay? And apparently if any ID if any tag has an attribute ID that's equal to link 2, you'll get it. In this case, there's only one. But if there were more, that's how I read it. You might have read it differently. Okay. Now, we're using that frickin' compile thing. It always seems to have to do with strings. And of course, we get the A tag that has that word LC in it. Okay. Now let's move on to this true-false thing. We talked about this a little bit in the last video, but let's talk about this some more.
You can filter an attribute based on a string, a regular expression, a list, a function, or the value true. This code finds all tags whose ID attribute has a value, regardless of what the value is.
Okay, so pretty much all you're saying here is if there's a tag and one of the attributes is ID, I want to see it. And as it happens, they're all the A tags. All right. What else can we do with the filter?
You can filter multiple attributes at once by passing in more than one keyword argument.
Okay, all right. So we want LC and linked. Now, if so I'm thinking if LC was linked 2, we wouldn't have gotten anything because I'm pretty sure they both have to be true.
Some attributes, like the data ** attributes in HTML5, have names that can't be used as the names of keyword arguments.
They can't. All right, this is where we start getting stuff that blows up. Okay, now according to this, we were supposed to get this keyword can't be an expression. But when I ran it using the more up-to-date Python, I got this. Expression cannot contain an assignment. Okay, so it's thinking that I'm saying set this variable that I haven't defined to this string. And then it gives me a hint. Hey, you can, if you say, is this variable equal to this? Because that's what the double thing does. And I guess I could have experimented to see if that worked, but yeah, why bother? Let's move on.
You can use these attributes in searches by putting them into a dictionary and passing the dictionary into find_all as the attrs argument.
Okay, now, in the example, we're supposed to get some sort of a this thing in the output. But when I ran it, I got an empty list. Okay, and I'm not so sure I know why that is. We got the data foo. It's there. We got the value. So they both should be true, so this should come through, but it doesn't. Okay, so that's interesting. Something to think about.
You can't use a keyword argument to search for HTML's name element, because Beautiful Soup uses the name argument to contain the name of the tag itself. Instead, you can give a value to name in the attrs argument.
Blah, blah, blah. Okay, all right. So, we're creating a Beautiful Soup object. All we have in it is this. That's it. Okay, and then we're going to say, is there an attribute with name in it? And apparently there isn't. So it comes back, empty. But then when we use do the attributes method, it hits. Okay, and we actually get this returned. Okay. Now, let's see, what did they expect? They expected this, and what did I get? Yes, that's exactly what I got. And here, I just threw in some extra examples of stuff in case you want to take a look at them. Just pause the video. You know the deal. Okay, here's a function, defining a function. That looks interesting. Here we are in my code. I'm going to just scroll through it slowly so you can grab anything that you want, any ideas. Feel free to appreciate how beautiful my code is. Oh, yes, I love my code. I know. You think I'm weird? Oh, you should have. You should have been around in the very beginnings of the programming era, man. There were all kinds of weirdos running around. We had people freaking talking to themselves. I had this one guy that would lock himself in the office and turn the lights out, and all you could see, the only light in the room was from his computer monitor, and nobody wanted to talk to the guy. Nobody wanted to interact with him because they're afraid that he might kill them. And guess who always got the call to go tell him to show up for a meeting that he would never show up to? I'm sorry. The PTS just kicked in there for a minute. Never mind that. All right, let's go ahead and take a look at some output. And here we are in the output. Man, I really wish I could do something to break up these lines a little bit, these run-on lines. That's bugging me. Another thing that's bugging me is every time I create a freaking beautiful soup object, I get all this freaking message. I don't care. No, I still don't care. Anyway, yeah. So yeah, I have to figure out how to do something about that. I don't like that. Anyway, the video is over. You guys go out and play, have fun, don't get into too much trouble, and we'll see you in the next video.